Hello everyone, still under entropy. We are going to discuss about entropy of the surrounding. And as I said earlier, that in any chemical reaction, a reaction can either be exothermic or endothermic. And the effect of heat loss or heat gain is always experienced by the surrounding itself. Now, to understand entropy, of surrounding, we always use a formula negative enthalpy change divided by temperature. And the temperature here, temperature that we'll use, is always given in Kelvin. It's always given in Kelvin. So, meaning, I'm given a reaction that is taking place at 25 degrees Celsius. What I'm going to do to get that given reaction in Kelvins is just going to be 25 degrees plus 273. Then I'm going to get that temperature in Kelvin. Now, the key thing that I want you to know, that whenever you want to calculate total entropy of a surrounding, can be shortened as that. You need a negative enthalpy change of that given reaction divided by the temperature upon which the reaction is occurring. Now, I'm going to give you an example of a reaction. And you're going to see how we can calculate its enthalpy. So the reaction is calculate of a reaction taking place at 298 Kelvin when 1 mole of oxygen, so when 1 mole of hydrogen is burned in plenty oxygen. You can be given a question like this. And just as I said earlier, the key thing that you need to know, you must be given a reaction for this matter. Maybe you were given a reaction and initially you are told to calculate the enthalpy change for that given reaction, and they can go ahead to ask you to calculate the entropy change of the surrounding at a given temperature. So I'm going to give you the reaction. The reaction is hydrogen gas reacting with oxygen gas, give you a mole of water. So the water can be either in gaseous state or can be in gaseous state, because the such reaction is always exothermic, and the delta H for that given reaction is equal to negative 286 kilojoules per mole. Now, when given such a reaction and the enthalpy, I simply know that to calculate entropy change of surrounding, I always have a formula at negative delta H all over T. And already the temperature we've been given in Kelvin, so we don't need to do the conversion here. So we simply introduce them into the formula. So I'm going to have delta S, the surrounding, is equal to the negative of negative 286 over 298 Kelvin. So if you do such a reaction, you're going to realize that the answer you're going to get here is simply positive 0.960 kilojoules per mole per Kelvin, because you divided a certain amount of enthalpy change by Kelvin. You can even decide to change it into, if you're asked that you're supposed to leave your answer in joules, you're going to divide that, you are going to multiply that by 1000, and you're going to get still positive 960 joules per mole per Kelvin. So that's a simple way and a simple example of how to calculate entropy of the surrounding. I'm going to give you another example, and the example I have here is that calculate, this is my example 2, in my example 2 we are told calculate delta S under standard condition of the surrounding at 298 when 1 mole of ethanol is burned in plenty oxygen. And 1 mole of ethanol is burned in plenty oxygen. The examiner is just trying to tell you that the reaction is going to completion. We have plenty of oxygen to ensure that the whole sample of ethanol that we are having burns completely. And we are given an example of a reaction here. So I'm going to have ethanol is C3, CH3, CH2, OH reacting with oxygen gas to give me CO2 gas plus water. So when you balance the equation, you're going to realize that I'm going to have a situation nearby. I'm going to put a 2 here because I have 2 carbons on the other side. And since I have 6 hydrogens on the other side, I simply have to bring a 3 here to make hydrogen 6. And I have 7 oxygens on the other side. So I need to make the oxygens on the reactant size 7. So I simply introduce a 3 here. So we are given that this whole reaction has a delta H of 1360 negative 1366.8 kilojoules per mole. Meaning whenever such a reaction occurs, that the amount of heat that is given out. So it's very simple. I'm simply going to key everything into my formula. We said delta S of surrounding is equal to negative enthalpy change all over the given temperature upon which the reaction is occurring. So my delta S under standard condition of the surrounding is going to be a minus of minus 1366.8 all over. The reaction is happening at 298 Kelvin. 298 Kelvin. So when I do that, the answer I'm going to get here is simply positive 4.587. 587 kilojoules per mole per Kelvin. If I decide to leave my answer in joules, I'm still going to get a positive value of 4587 joules per mole per Kelvin. So that's the simplest way on how we can calculate entropy of surrounding whenever we are given the enthalpy change of a given reaction and the temperature upon which that given reaction is happening. So you simply have to remember the formula that we are using and how to key in the values given and how you can come up with a given answer in calculation. Thank you very much and have a wonderful time.